This is John Gilroy here from the Constellations Podcast. We recorded this interview at the Satellite Show in Washington, D.C. We were lucky enough to have three experts in satellite communications, and they will tell you exactly how space communications is becoming more and more like space IT. Hit the music, Claude.
Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I will be your moderator. As you may know, digitally transformative technologies have been making their way across the satellite industry all through the show here today, from the core to gateways, in orbit, and on the ground. There's no denying that space communications is starting to become more like space IT. Today, we have a panel of experts to talk with us about how this transformation is happening at the edge of the network specifically, and what that means for the industry in general. Our distinguished guests are Dallas Kabowski, analyst for Northern Sky Research, Kevin Tobias, director of product management at Kratos, and Jack Waters, CEO at XipLink. I'm going to jump right into the conversation. Dallas is to my right, so I'm going to start right here. You ready?
I'm ready.
So Dallas, the satellite industry has been changing. The space layer has been experiencing innovation like software-defined satellites, multi-orbit constellations, which has met with a bottleneck in the ground system. So can you talk a little bit about these drivers and explain how ground systems have been changing to account for the new space innovations?
There's a lot of transformation happening in satellite and on the ground. Basically, we're all here. We're all here at the satellite show, but we know that satellite has been removed and separate from the rest of the networks. So from hardware to software, we're seeing complexification, added capability. In terms of the drivers, the main driver is just to reach more customers. The whole aspect of satellite is to go global, but then you run into the fact you can't meet with any of the telcos, you can't meet with any of the other service providers, so there's a lot of innovation happening from software-defined satellites, as you mentioned, and on the ground we're looking at network architecture and infrastructure, I'm sure others will talk about, just trying to make that layer less special and more integrated with the rest of the network.
So Dallas, let's talk about terminals here. All kinds of terminal vendors here, software terminals. Let's look specifically at the terminal market for commercial SATCOM. So what is the state of that part of the market, and how is it changing?
There's about 24, on the show floor, there's probably several dozen manufacturers, but whether or not we're talking about GovMil versus commercial is a completely different story. But for those who are commercial providers, we got 24 players on the market looking to offer mechanically or electronically steered terminals. And what we're talking about are different kinds of antennas for air, ship, land, and fixed enterprise, and eventually consumer broadband. And that's half. That's what we've been seeing here the last few years. Depending on the booths that you go to, we're also seeing Starlink. We're also seeing Amazon, they just talked about today. So we're seeing a lot of big players trying to put out flat panel antennas or other kinds of electronically steered equipment in order to narrow that gap, again, between satellite and the ground.
Well, Dallas, we're here in Washington, D.C. There's a school up the hill called Georgetown. I'm sure at Georgetown there's English 101. So I'm going to ask you a satellite 101 question here. Kind of a basic, I think it's basic, but you can riff on this a little bit, I'm sure. What is a terminal, and what are the different types of terminals in operation today?
Yeah, so a terminal in the satellite world is an antenna, which includes the electronic equipment necessary and a modem. It's the whole package. So sometimes a lot of the manufacturers talk about antennas, and they're only talking about the dish and the electronics behind them. But a terminal is the whole package. It's the whole thing that not only enables connecting to the network, but manipulating the signal in order to connect to different networks and things like that. In terms of what's available, any curved dish you see, often called VSATs, or very small aperture terminals, or in the case it's over here, very large. So you have the parabolic, and you have flat panel. This flat panel can be a literal flat panel that's on a rotating gimbal, mechanically steered, or the fancier ones are electronically steered. They just look like kind of an LCD screen or a ceramic dish. They just sit there, but behind the screen there's a lot of electronic steering and beamforming capability.
I was going to have Kevin sign up for a free T-shirt, but he already listens to the podcast, so he's listened for years, many, many years. Same question to you. We can expand on this a little bit. I'm sure this is a topic that maybe people can kick around a bit. So what are the components for you that make up a terminal?
Sure. So I'll just build on what Dallas talked about. Terminals, specifically at the remote site or the far edge of a network, are providing connectivity to a number of different use cases. So depending on that use case, it will drive the configuration of that terminal. So a few, just for example, you have fixed use cases where you might have a parabolic that's pointing at a geosynchronous satellite, and it's just providing trunking connectivity or cell backhaul to a remote site or a remote island. Then you have use cases like comms on the pause, comms on the move. More generally, we'd call it mobility. Those terminals are providing connectivity while that application is on the move. So think trains, planes, boats, automobiles. And depending on each one of those use cases will drive what components build up the terminal. So we start at the antenna aperture, and that antenna aperture is connecting to the satellite at the frequency of the satellite. Stepping that down, we take it from the satellite frequency down to an intermediate frequency called L-band, and we do that with a buck and an LMB. These are the components that make up the antenna. Then at L-band, that analog RF spectrum is taken in through a modem, and that modem is ultimately the network function that takes care of the modulation, demodulation, and sends out IP traffic. So those are the main components of a terminal.
I have to warn you that Jack has survived one of my podcast interviews before and only minimal mental damage, maybe a few trips to the psychiatrist to recover. So Jack, got to pick on you a little bit here. In Washington, D.C. here, we got a lot of podcasts about technology. There's one podcast called Feds at the Edge because they talk about edge computing and sensors and military and train sensors, by the way. So Feds at the Edge are everywhere. And so we see the edge being talked about constantly. I think it's almost a trending phrase. I'm sure at Google Trends you'd see edge coming way up. So let's talk about the edge here, Jack. So in modern networks, the ones we have in town here, the edge is the place closest to the end user where edge computing potentially can occur. Now, the terminal in the satellite communication network edge, but computing doesn't take place there. So as data is relayed back to, I think, to the gateway technically. So can you share with us your knowledge on how telcos work on the edge and how that differs from satellites?
Yeah, I'm going to start there by going 25 years back, right, where SATCOM was very proprietary, and the SATCOM industry rallied around TCP/IP networking, so there was some sort of level playing field, at least for the data packets. So, companies like iDirect, perfected those kind of things, Hughes, the other vendors. And so the telcos, the satellite vendors, everybody used TCP and IP as a universal transport layer to move everything. Now you fast forward to today, and the telcos are building out edge computing capability, maybe not all the way out to where the customer is, but darn close, right? And the long-term idea is to compute some of the items locally, right, before you deliver it to the customer, and don't even send it back to the central office. So you might, take off some, on the video surveillance or something like that, you might take off some of the picture to minimize the amount of data to go back and those kinds of things. Satellite is the ultimate edge, right? Because you're typically bandwidth limited, and therefore you'd want to obviously do remote computing as far out as you can. It's actually evolving now to the point where telcos don't use it much yet. They're looking for killer applications. So it's not all that much different than the satellite business today. What's quite different, though, is that the telcos today use software-defined networking to actually build the service automatically because they reach so many endpoints. And now the SATCOM business is following with software-defined networking to have a software way to build the service from start to finish and have a higher, faster deployment capability. And that's a little bit of edge computing because you have to have some compute intelligence at the remote side to do all that.
But years ago when I studied VoIP, I learned about COs. I never thought there'd be a connection between a central office and a satellite, but all those barriers are being destroyed, aren't they?
Yes, they
Everything's new now. You can't limit one term to one field anymore. You can't silo that vocabulary. So Dallas, I want to ask more about this edge and this whole concept of edge and satellites. So what about the satellites? Can the satellite itself be a network edge and run edge computing on board? Can it run it on board?
Soon. Yeah, I mean, we're seeing the development. Just building off of what Jack was saying, we Software-defined satellites is the next big thing in communications. We're seeing satellites that are capable of transforming their beams, changing their signal. I mean, we've had the ability to change the location of the beams, but now we're changing frequency, all this kind of stuff. Just adding flexibility on orbit and the ability to actually change the satellite's mission after it's been launched. So we're seeing a lot of push to try and do that, and that's on the comms side. You have other applications. You mentioned surveillance. Well, in Earth observation, one of the problems of Earth observation satellites is they downlink a lot of data that they never use. It's all full of clouds, it's bad weather, it's bad signal. So the ability to tell your satellite, remove anything that's irrelevant to me before downlinking can save time, can save money, and those industries are hard at work at trying to get edge computing on satellites today.
Well, let me state the obvious. I have gray hair and Jack has gray hair, and we probably remember a song David Bowie called Changes. You probably remember that. Some people think it's ancient history. But I want to talk about changes with Kevin. Let's talk about changes. And we're going to talk about changes in space, maybe changes in space, changes in attitudes, mostly changes in the traditional terminal. So how can they be responsive to all these changes we see with software-defined networks and software-defined satellites?
Yeah, so as the space layer continues to just innovate and become more dynamic, the ground really has to adapt. And so one of the main ways that we can do that, first and foremost, is making sure that the edge, the terminal, is open and standards-based. The next approach would be virtualizing the network functions that were traditionally physical. And so what this does is, by virtualizing the network function, we can disaggregate the network function from the proprietary hardware that it's running on. And so once you do this, the vision of converging with terrestrial technologies becomes a reality, right? So all the network functions that are being run on general purpose compute at the edge, we can then take the network functions I talked about, like the modem, we can virtualize that and run it on the exact same platform, which allows us to orchestrate it like it's a part of that edge. And we can start to think about the edge more holistically, about the solution that we're providing instead of just one specific network function and it kind of being on proprietary hardware. So those are the main things: is open, standards-based, and virtualize.
Last week I did an interview with two real bright engineers from a company called Rivada. And really intelligent. We had a good conversation. A lot of engineers floating around here, but many of them can't connect the dots. See, most of the people in the audience here, they look at this technology and say, well, what's in it for me? Can it save me money? Can it make me more flexible? Can I leverage existing assets? Can I increase revenue? And so that's the question, is what's in it for me? So Kevin, what are the main advantages of software-enabled terminals to satellite operators and end users? What's in it for them?
Sure. So a lot of flexibility comes once you virtualize and can run on that general purpose compute. So a couple of things. This concept at the edge where we virtualize network functions and run them on general purpose compute is called universal customer premise equipment, right? So we're able to leverage the economies of scale that exist within the UCP market that the telcos and the CSPs have been taking advantage of for many years, right? So we're able to run in that exact same environment. We're then also not locked into a specific vendor because we're disaggregated. So whatever the use case may be, we can go to the vendor of our choice, pick the right size compute to build out that edge that we're going to deploy and make sure that it's a shoe-fit solution instead of a one-shoe-size-fits-all approach to it. And there's other things that we start to think about. During the pandemic, for instance, supply chain was the big story, right? So if you're tied to one vendor and you can't get delivery of that specific modem, how do you answer, right, the business demands, the network changes, if you're locked in, right? When you take a more open approach with UCP and can run on general purpose compute, you can go and pick from the vendor of your choice, mix and match network functions.
The Constellations podcast was launched back in 2017. It was a small step for man, but a giant leap for podcasting. Today, thousands of people from all over the world listen to Constellations, and thanks to you, we've grown into more than just a podcast. Sign up for the Constellations newsletter to receive articles on current industry issues, podcast summaries, and contributed blog posts at constellationspodcast.com.
I would like to direct everyone's attention to this little pull-up here. It talks about our hot topics. You know, we've done over 150 podcast interviews, all kinds of topics. We have the 5 hot topics here. And also, there's a QR code to get a free T-shirt and sign up for the podcast. But we like to talk about hot topics or trending topics. Imagine a lot of people today are interested in trending topics. And a big topic today is the convergence of satellite networks with telcos and mobile network operators. It's been a hot topic. I mean, they got the MNO. I think they got their own acronym, so that means something, huh? So, question for Dallas is, can you fill us in on how digital transformation in the satellite industry has been affecting this relationship?
Absolutely. So, direct-to-device is another hot topic. It's a buzzword that's been really, everybody's talking about it. You're seeing big deals now in the industry, Apple, Globalstar, Starlink, and T-Mobile. Basically what's happening is satellite is figuring out how to properly communicate and address telcos and mobile network operators, MNOs. They're filling that gap. They're narrowing that gap with the technology, digitally transforming what they do in order to disaggregate. A lot of buzzwords, but essentially they're narrowing the gap technologically speaking, and they're realizing we can work together. We can work with the same addressable market. We have the global reach. Satellites literally have the global reach, but they can't reach the customers, whereas the operators, that's what they do. So they're really looking to try to make it so that we don't need terminals, we just need phones. That's one of the biggest things that's happening is direct-to-device, satellite-to-device, with cooperation with telcos and the mobile network.
Jack and I have been around. We've visited a lot of company websites, and the trending phrase on company websites now is digital transformation. Everything is digital transformation and digital this. So, Jack, from your perspective, what do you believe the advantages are of a new digitally transformed terminal model for telcos? Digital transformation.
Yeah. Kevin hit a little on it. Number one, cost does drive a lot of things, right? Us vendors can all add value and try to sell it for a certain price, but, cost is still king. And the number one thing is customers are going to save a lot of capital costs using this general purpose compute. Go buy your Dell server, go buy whatever server. So that alone has a huge cost impact on it. The second thing in today's world, as an older man, I'm always amazed how fast things move today. So everybody is expecting quick service, right? If you order it and you have to wait 6 months or 8 months, that's just too long. And so the ability to profile and issue a service in minutes instead of months is huge. And so I believe the customer satisfaction will build as a result. There's a second technical thing there, which is there's fewer errors. So once you build this software definition for services and clean out all the errors, it just replicates accurately over and over again. So that should help with the customer satisfaction, the customer take rate. And I think that's one reason that the MNOs, by the way, will start to come together with the satellite companies, because satellite has been very difficult, and it was only 2% of the telecom market. So they were more like, hey, let me hand it off. So it'll have an effect on the integrator, the middle person that has to fix all these things and make it run. It's certainly going to operate a lot smoother, but luckily we need somebody to put all that infrastructure in place. So the integrators are safe.
I have a background in radio, 25 years on radio, and on radio you can say, hey, that's the phrase that pays, and get a Cupid doll or something. And so, Jack, you use the phrase that pays, and the phrase that pays is general purpose compute. And that's what the feds at the edge talk about. They say one of the advantages of having a intelligence at the end, you can do compute at the edge of the network. And they talk about that a lot. So I have a question for Kevin here. So if a terminal is running on general purpose compute, as opposed to, I guess, purpose-built, what does that mean with regard to value-added applications and other functions? Is there a conflict there?
No, there's a huge value here, and I think one of the main things I would point out is this really future-proofs your operations, right? So as business needs evolve, network changes happen, you're able to spin up new network functions as you need them. Instead of having to actually go send an installer out to that site and have to provision that network function, you can spin up a second modem, you can spin up a second link, you can spin up an optimizer, you can spin up a firewall. Whatever you may need at the edge to fulfill that solution, you can orchestrate it all on one platform instead of those things all being disaggregated from each other in such a way that you have to go into each network function and tie them together with cable. So I think the important thing to note is that future-proofing aspect and the zero-touch provisioning that comes with running on general-purpose compute and those third-party value-added applications really bring extra power in terms of delivering the end solution.
So Jack, we're going to pull a phrase from Kevin here, and the phrase is value-added applications. Let's talk about those. So when it comes to value-added applications, what is the difference between how they're deployed typically in a satellite and how they're deployed in a terrestrial network? Are there differences?
Well, certainly. I mean, if you think about cloud computing and its integration with telecom right now, because things are not virtualized oftentimes in SATCOM, you can't just spin it up on a cloud, right? It's not digital, so you can't just quickly spin that up. So telcos can do that with their standard telco products today, and soon, hopefully in the next couple of years, they'll be able to do that with SATCOM as well and build a service all the way in. And let's pray that we can also do end-to-end. So a telco service that's continued with SATCOM all the way to the endpoint in a software-defined manner. So yeah, I think it's going to be possible. The satellite industry has to jump this divide, from old ways to new ways. When I say fairly quickly, within, a couple year period of time. The virtualization side has already started, so, we're almost there. We just got to complete that. And then now the telcos are becoming more interested in SATCOM for two reasons. One, you mentioned direct-to-device. That's kind of outside of my purvey, but that's very interesting to the telcos. And the other is to reach the unreachable, the people that have not been able to reach so far. And they won't do that, the mainline telcos, until they have a soft ability to define it all the way to the edge service, because it's the only way they're profitable.
So Jack, earlier you used the phrase software-defined network. And in my interviews for Constellations, I've used software-defined satellite, software-defined space, software-defined everything, So when network functions are deployed as software, how does that affect the business model for value-added apps and the deployments for satellites? How about the bottom line here?
Yeah, well, it's interesting because, the vendors of software like XipLink traditionally had to use proprietary products, so they were very costly. And now we can just buy off-the-shelf compute, so that's good. But from a business opportunity standpoint, the whole edge computing atmosphere is very interesting. We're only really now taking the first steps into edge computing, right? We're putting things like cell backhaul, something we do, with Kratos right now. And we add that value into the edge compute, right, in order to take cellular data in effectively. But once the computing power is out there, we're going to see what kind of applications come about and are sold. I think we're going to be here a few years from now going, oh, wow, that was a killer app. We didn't know what it was today, but it's going to be allowed to run on the edge compute platform that's being built today. When
you listen to radios, people use this phrase, final word, where I'm going to give each person here the final word. We're going to start off with Dallas, and we're going to use that phrase that's bandied about all the time, that phrase digital transformation. Probably means 53 things, 53 different people here. So Dallas, first question to you. Digital transformation is undeniably creeping into all aspects of satellite networks. I'm sure each of you have different perspectives on this question, but for each of you, look 10 years down the road, if that's possible. Look 10 years down the road, and how would you describe the satellite networks of the future, the next decade?
I'll start from the satellite perspective. We're talking about narrowing the gap. In 10 years, with all the functions being digitized and all of the flexibility being improved and a lot of adaptability post-launch, basically on the satellite side, the satellite will be a vital component in any network. If you're a telco, if you're an MNO, and you want to go global, you will have a satellite or several or a constellation as part of your fleet, and that will be enabled by digital transforming processes that actually allow your satellite and the rest of your network to communicate cohesively.
Jack, jump in.
Well, first of all, I'm going to be retired in 10 years. So
who cares?
Maybe I'll make it a few years, into the process, and I'll probably be a user of whatever nice services come about in 10 years. Hopefully it's out on the golf course somewhere. But, no, I mean, I've been in telecom before I was in satellite. It's always about bandwidth. It just keeps growing and growing and growing. Back in the early days, it was kilobits, and recently it's been, hundreds of megabits, and it's going to be gigabits in 10 years, no question about it, right?
Yeah.
Video surveillance and very high-speed computing, low-latency access, those things will be very, very important in 10 years.
Mr. Kratos, go for it.
Sure. So I can't help but think that within 10 years, we'll be in a place where we're not just talking about connecting certain things. It will be Internet of Everything everywhere at a moment's notice, whenever you need it. Another thing that comes to mind is seamless connectivity. I think we'll be in a place that from a user experience perspective, non-terrestrial and terrestrial networks will have converged to such a place that as the user, you don't know if you're using 5G, 6G, satellite, Wi-Fi, makes no difference. It's transparent to the end user. And then the last thing I would say is I think it will be more autonomous than it is now. I think that the edge, the gateway, the core, they become more cognitive, are able to infer, make decisions on the network without the user having to actually touch the system.
The guy who designed 5G is named Ulf Edvardsson, and he told me there's a new G every 10 years. So I don't know about the next 10, 15 years, maybe you'll see 5, 7, 8G. That's a whole lot of G's, I'll tell you something. And this is a great T-shirt right here, ladies and gentlemen. Come on down, get the QR code, get this fine T-shirt. This is a Space Cowboy T-shirt, guaranteed in writing to have fun when you wear this T-shirt. I'll guarantee everyone it's a fun T-shirt to have. I'd like to thank my guests for this great discussion. Jack Waters, CEO at XipLink, Dallas Kasabaski, analyst for Northern Sky Research, and Kevin Tobias, Director of Product Management for Edge Solutions at Kratos. Give them all a hand. Thanks, guys.
Pleasure.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.